the algorithm which helps us in identifying among millions of transactions what are the most common frequent item sets, or what you call as frequent association rules. First step, what you say, is to identify what is that set of X union Y. That's what we call as frequent item set to be identified. So there's one important property here which is very nice. It says that if you have a frequent item set, a priori property says that the subset of that is also a frequent item set. So this helps us in eliminating those where we don't have subsets which are supporting the what we call as being a frequent item set itself. So what is that algorithm which we do? It's very simple. Let's show with example. Let's take this example. We start with a scenario where we talk about the support being 50%. We talked about, let's take the 4 transactions here. We see that we start with one array item set. The item set with 4 has only support of 1, so which is less than the 50%, which is 2. So we drop it. Then we go to next level, which is basically taking on the role of expanding it to 2-array set. Here again we find that the set 1, 2 and 1, 5 do not have more than 1, which is 2 or more, so we eliminate them. So you're left with 3 of size 2. You expand that, you see that there's only 1 which is of size 3, which is satisfying of minimum support of 2 or above. Then we look at collecting all of this and finding out the potential candidates which is going to give you your target X union Y. That is done by eliminating, pruning scenarios where subsets are not themselves frequently identified. So probably at the end of it, what you do is you get a item set which is k-array item set, which is going to satisfy your minimum support criteria. But the next one is about your rule should also satisfy what is known as the confidence. So here we try to create all kinds of combinations out of the k-array item set, the set of rules you can create. Let's take I1, I2, I5. We say that we can create I1 and I2 implies I5, I1 implies I2 and I5, or I2 implies I1 and I5. All kinds of combinations you can create. Then what you do is you can actually take a look at all these such combinations and find out where you're not able to support the required confidence. I mean, you're not able to generate required confidence, and you remove those combinations. And in the end, what you get is the ones which are satisfying your minimum confidence criteria which you wanted. If it's 90%, here we only have 3 sets which are satisfying. So I1 and I5 implies I2, I2 implies, sorry, I5 implies I1 and I2, and I2 and I5 implies I1. So this is basically a very important element which is useful in the context of what we call as association rule mining.